Hello everyone. I am Indrajyoti Gaine. I am a PhD scholar from the Department of Mathematics and Statistics, IIT Kanpur, and presently I am a PMRF fellow. And before that, I was a CSR fellow, and I have cleared my CSR net with 108 rank. Okay. So in the previous lecture, we have discussed about relation and functions. So now specifically we will talk about in this chapter, in this lecture series, about the trigonometric functions. So for that, we have to know first that why this trigonometric function is so important. So trigonometric is the Greek word which is a mixture of two words, that is trigon and metron. Okay, that is the main motive of this topic is measuring the sides of triangle. Okay, so usually people in ancient time they use this kind of functions and they use this kind of concepts to find the direction in the middle of the sea when they use the ships to go from one country to another country. Then they use this kind of methods. From that purpose it came, and presently it used in the seismology and designing electric circuit, like all this electrical field. It is very much useful. Okay, so the main concept of this thing is the first concept of before we go to the trigonometric function, we need to know about what is angle. Okay, so angle, we know about angle a little bit. So let me discuss little about the angles. So let us assume that this is our initial vector. This is our initial vector, name as OA. Okay. Now someone going in this direction, along this direction. Okay. So presently this vector ray is at this position, suppose. Okay, I am calling it OA dash. So it was previously at the position OA and now it is at the position OA dash. So this vector ray shifted in the anti-clockwise direction little bit. And now the thing is how much this vector direction has shifted. This is the question. Now, how can I measure that how much this vector ray has shifted from one position to another position? Like whenever we talk about displacement of some element, then we say that this is our space. Suppose this is our space. So before the particle was at this point, and later the particle went to this point. So from this point to this point, here is the displacement. Okay, displacement. And how we measure how much displacement this particle had, that is by the distance between the present and the past position. Okay, so this length or distance between these two are considered as the displacement of this particle. Now what about this? Here you can see that this origin, that is vertex, we say this O point is vertex. This point is fixed, but the point A is shifted to A dash in anti-clockwise direction. Okay, so this measurement is considered as the angle. Like this is called angle. Here it is called distance. Here it is called angle. So angle is a measure of a rotation of a given ray about its initial point. Okay. So what is angle? So angle is a measure of rotation of a given ray about its initial point. Okay, so this is called our angle. See, usually any angle is denoted by theta. Okay, any such kind of angle can be denoted as theta. Now check that this is the anti-clockwise direction. movement of the ray was along the anti-clockwise direction. Now, in some scenario, it can happen that the initial ray was at this point OA, and keeping the O point fixed, the A point moved along the clockwise direction, and the future position of the ray becomes this. Okay, so here we can get another angle. This is also an angle. Obviously, this is an angle. Now the thing is, if you compare these two figures, you can clearly see that I am measuring the rotation of the ray from the initial position. So in the previous case, the initial position was this line, this blue line. Okay, and in the later case, the initial position was again this blue line. Okay, and this arrow denotes the which is the direction of the rotation. So depending on this direction of this rotation, it is clockwise rotation. This along the clockwise direction, clockwise, right? So depending on this direction, we say this is our positive angle or positive theta. This is our positive angle, and this is our negative angle. So what is positive angle? What is negative angle? Positive angle is if the initial ray and terminal ray makes an angle in anti-clockwise direction. Like starting from the initial ray, the terminal ray goes in anti-clockwise direction. Then we say the angle is positive. And if the ray starts from the initial position and go to terminal position along clockwise direction, then we call it negative ray or negative angle. Okay. Now, so this is called our initial side or initial ray. You can say this is our initial state. Better is you can say this initial state. This is our initial state, and this is our terminal state. Similarly here, initial state, and it is called terminal state. Okay. So now the question is, one can say that what about this? This is our OA, and the later position was this OA dash. This is our position O. So this is our initial ray, and the red one is our terminal ray. Okay, this is our initial. This is our terminal. So in this case, depending on our scenario or depending on our requirement, we can measure the angle along this direction or this direction. Okay, so in both the if you approach both the side, along clockwise direction or anti-clockwise direction, you will get the same measurement. Okay, so in this case, both will be same. Now, what about this case? This is our initial ray, and this is our terminal ray. That is, our initial ray and terminal ray is overlapped. Okay, so this is our starting point O. Blue A is the initial for the initial ray, and red A dash is for the terminal ray. So in that case, one can think of the displacement is zero, like angle between these two rays are zero because there are no displacement. Or else one can think like this, that the ray had started moving from this point and it completed a complete rotation and came back to the original position. So in that case, it is called a full rotation, a complete revolution. So in this case, we can say either no rotation or no rotation, or a complete rotation. No rotation or a complete rotation. Okay. So measure is what is the measure of an angle? So angle is this. We highlight this definition. And what is the measure of the angle? Now I know what is angle. Angle means this measure. Now measure of the angle means which amount of the rotation happened in that case. That is the measurement of the angle. Okay. Okay. Now we usually measure this angle using two kind of measure, like degree measure and radian measure. So measurement of angle is of two type. One is degree measure and another is radian measure. Okay, so one is degree measure and another one is radian measure. So what is degree measure? So let us discuss about this thing first. Okay, so suppose in this case, consider this case. Okay, so I am redrawing this image again. So this is our initial point. This is your initial ray, and I am just overlapping on it so that you can understand properly. But the position of these two rays are same. Just for understanding, I am drawing this red line over the blue line. Don't get confused about this thing. This is your vertex A, O. This is our initial ray. So this is for blue, and for terminal, this is our S. Now I am assuming that we had completed a complete rotation here. We have completed a complete rotation here. Now I am dividing this complete rotation by 360 different segment, equal segment. Like whatever we have done in the case of real lines or real numbers, we divide it like in case of natural number. In case of natural number, what do? We do 1, 2, 3. Like we are taking unit distance or unit step from one to another. Similarly, we are equally dividing this complete rotation into 360 units or 360 parts, and each part standing for 1 degree. Okay, so what is 1 degree? 1 degree means if a complete rotation is happening, and if I divide each whole rotation by 360, that is 360 different segments, then each segment is called 1 degree. Now a degree can be divided into 60 minutes. Okay, so let us write some important parts. A complete rotation is equals to 360 degree. Okay, so why 360 degree? Because we are dividing this into 360 parts like this. It is became more than 1 degree, but I am just for understanding, I am drawing this thing. So a complete rotation is considered as 360 degree. Okay, now 1 degree, if I divide 1 degree by 60 parts, then each part is called as a second. So 1 degree equals to 60 seconds. That is called means 60 seconds, and 1 second is standing for 60 minutes. So with the help of this degree, second and minute, we can measure a angle between two sides, initial side or initial ray and terminal ray. Okay, so this is one kind of measurement. So let us see some example of degree, how we can understand a degree with degree angle, how we can say that this thing. So first of all, this is 360 degree. Whatever we have assumed by this statement, we already have this statement. So this thing clearly implies this angle is denoting 360 degree. Okay. Now what about this angle? This and this. This is our 180 degree. Now I have discussed here that the angle is in this negative direction or negative angle. Now if the terminal state makes equal distance, I mean displacement of the terminal side is same from initial state or initial side, but the direction is one case in clockwise direction and another case is anti-clockwise direction, then the angle will change the sign. Okay, so when angle changes the sign, suppose assume that this is our initial state and this is our terminal state. We already knew. Now the displacement from here is theta. So theta. Now the thing is, in this case, suppose in this case, OA and OA dash are initial state and terminal state. Now the thing is, suppose the displacement of OA dash from OA is same as OA and OA dash in previous case, but in opposite direction. Here it is in clockwise direction. So the angle will be minus theta. So for example, here it will be clear. It is our initial state. In this case, initial state is blue and terminal state is red. So in the positive along the clockwise direction, along the anti-clockwise direction, the rotation was 180 degree. Okay, so I am saying this is 180 degree. But if I go along the clockwise direction, then also it will 180 degree. In that case, I will write minus 180 degree because it is anti-clockwise direction. So depending on the sign of your angle, you can clearly understand the rotation is in clockwise direction or anti-clockwise direction. Clockwise direction negative, anti-clockwise direction positive. Okay. So this is obviously 360 degree. We discussed in the next example already. Okay. Okay. Now let us see some more example which are very, very much familiar to you guys. So yeah. So you all know about right angle triangle. So right angle means this thing. So this is our O A dash. So this is our angle. Now, which direction it is going? If I say this is our initial state, this is our terminal state, then this is in positive direction, and the angle will be 90 degree. Now, if the similar thing happen in opposite direction, like it is our OA and this is our OA dash, then this is called our minus 90 degree. Fine. Now the question is, if I draw this case again, like here and here, this is our initial state, this is our terminal state, and if instead of going in the clockwise direction, can I go in the anti-clockwise direction? The answer is yes. In that case, the angle will be 270 degree. So clearly you can see the whole rotation, that is a complete rotation, is equal to 360 degree. Whatever is here and whatever is here, if I add these two, like if I say this is our 90 degree, minus 90 degree, and this is 270 degree. Now depending on this rotational direction, I am saying 90 minus 90 degree. This is not like if I add these two and this is subtract or add like this, not like that. Depending on the direction, I am putting plus or minus sign. Fine. Now you can clearly see this is the measure. If I omit the direction, so the measure is here it is 270 degree, here it is 270 degree, and here it is 90 degree. Now if I add the measure, you can clearly see 270 degree. Okay. 270 degree plus 90 degree, which is equals to 360 degree. Similarly, here it is, you can find 180 degree, 180 degree plus 180 degree equals to 360 degree. Here you can find, I have stated that this is either no rotation or full rotation. So no rotation means 0 degree and full rotation means 360 degree. So which gives us 360 degree. Okay, so clearly one can understand from here that whichever, from initial state, in whichever direction the terminal state will be, if I go along the positive direction, the clockwise direction, and if I go along the anti-clockwise direction, the sum of the angle will be equals to 360 degree. So by this process, one can find whichever angle they need. If they know that this angle is 90 degree, then they easily can find that this angle will be 270 degree. They don't need to find how much angle, they don't need to use any other instrument to measure this angle explicitly. They just can subtract 90 from 360 and they will get this acute angle, bigger angle. Okay. So by this process, we can find two angles between the initial state and terminal state. Okay. Now let us see a few more example. Okay. So there is another example you can see in your book of NCERT, that is this example. Okay. So if I say this is our initial state, this is our terminal state. Now the question is, we know or we can measure that this angle is 60 degree. Now one thing can happen, that this terminal state started from the initial state and it completed on one complete revolution. It completed a complete revolution and then ended up at this point. So what will be the measure of the angle? So I know this is 60 degree, but this initial terminal state started from the initial state and it completed a complete revolution and then ended up at that point. Then this will be a complete revolution is standing for 360 degree. 360 degree and a more 60 degree rotation have been done by this state. So total 60 degree, which will give us 420 to 20 degree. Okay, so thus we can measure how much rotation the terminal state had from the initial state, and depending on the sign, one can say it is in along the clockwise direction or it is along the anti-clockwise direction. Okay, so till now we have discussed about degree measure. Now we will discuss what is radian measure. A very important part this is. So what is radian measure? So in this case, let's just notice that we don't know how much distance is covered. Just we have divided this segment in equally 360 parts, and we called each segment equals to 1 degree. Like this is our suppose 1 degree, this is our 2 degree, this is our degree 3, this is our degree 4. For understanding, I am making it a bigger picture, but this is not like 1 degree to degree. These are 1 degree is much smaller than this measure. I am just for explanation. I am trying to explain this thing this way. Okay. Now, how can I measure an angle with the help of radian measure? So radian measure is very much important thing. So how can I measure this? Suppose this is our initial state. Just draw it through. And this is your terminal state. Okay, terminal state. This is the origin O. This is the initial state. This is your terminal state. Yes. Now I need to find the angle between this with the help of radian measure. Okay. So before that, we will know what is 1 radian. Like we understood here that what is 1 degree. A complete rotation whose 360th, that is 1/360th of complete rotation equals to 1 degree. Like you can write here 1 into 360 into complete rotation. This is equals to 1 degree. Okay. So this thing is okay. Now what is 1 radian? So for this case, we need to draw a unit circle. Okay. We need to draw an unit circle. So let us draw this in different color. Okay. Purple and green. So suppose this is our unit circle. Green is bad choice. Sorry. This is our unit circle. Suppose. So by this we can say this is 1 unit. This is 1 unit. Right? Because your unit circle means the radius should be 1. So this is 1 unit. This is 1 unit. Now when this distance covered by this arc length should be 1, then I say this angle is 1 radian. This theta equals to 1 radian. Is equals to 1 radian. So is this clear? So we are drawing a circle of radius 1, and we are finding when the arc length is 1, then we are saying the angle made by this due to this arc length is called 1 radian. Now definition of 1 radian is clear. Now one can ask that instead of 1, if I want to know about any other unit circle, instead of unit circle, I can use a circle of radius r. If I use circle of radius, what happens? So in that case, just understand from here. So let's start. This theta is 1 radian. So I draw this in different color. So this purple. Okay. So let us draw a circle of radius r. Okay. So in this case, the radius should be this. This is the initial state. So and the distance is r. This is our terminal state, and this distance is also r. Okay. Now 1 radian is if this arc length is r, then we call the angle made will be 1 radian. 1 radian. So clearly observe one thing, that in either case, like if I scale with r, if I don't scale with r, the 1 radian case will be same, that is the theta or measure of this theta will be equal. Either I scale with r. If I take a circle of radius r or l or p, then we need to find arc length of r or p. Okay, that's why we took a circle of radius 1 and arc length of radius 1, and that will be the universal representation of 1 radius. Okay, now the question is, it may happen in the case of angle, or in the case of degree measure, we have found, we did something manipulation to find how to measure an angle. Like if someone give me an angle, like this is our initial state, this is our terminal state, and someone asks me about angle, then we measure that how much measure is in degree, then how much in second, and how much in minute. Okay, but here we had a universal rotation, like we are just dividing a complete rotation by 360 and taking each segment as 1 degree, and then we are measuring the other things with respect to these things. Now the question comes here that what about the radian case? So in case of radian, we can do like suppose. So I am drawing it again, otherwise it will be difficult to understand. So okay, this red should be taken. So suppose this is our r. This is our r. Obviously, this is bigger than this angle. This angle is bigger than this angle. If you compare these two, you can clearly see that this angle, the second angle, is obviously bigger than the first angle. So it cannot be 1 radian. Okay. Now how can I measure this? Okay. So again, I will take a unit circle around this vertex O. Okay. In the clockwise direction, you can, anti-clockwise direction, you can say. Usually people measure or do everything with rotation kind of things with respect to in anti-clockwise direction, and they choose anti-clockwise direction in the positive and clockwise direction as negative. Okay, so you took a circle of radius 1, so this will be 1, this will be 1, and suppose this arc length is some m. Okay, then we say this theta equals to m radian. Theta will be m radian. Now this m can be anything. It can be 1, 1.5, 2, 5, 7. Anything can be happen. Anything can be happen. So depending on that, the angle, this theta will be m radian. So just look at the difference. We are defining what is 1 radian depending on the arc length. Arc length should be equal to the radius. Then I will say the angle made by the arc length will be 1 radian. And depending on that measure, we are defining other measures with the help of that. Okay, so that's why we took one unit, so that it will be easy to understand. So one can ask that if I, in this case, if I choose a circle of radius r, what will happen? So let us discuss that. This circle of radius r, this is circle of radius r, suppose. So obviously this part will be r, and this part will be again r. And obviously the arc length will not be m in this case. It can be some l or p, something like this. And we know that this is our m radian part. Like it is your m radian. So clearly from that thing, whatever we have discussed from here, that r case, this r case, we can write here that you can write here that this m equals to L by R. Depending on that, we can write this. Why this? Because whatever we are doing here, that r by r, right? So similarly we can say this is l by r case. So from here we can say length l, that is the arc length l, equals to radian into radius of the chosen circle. This thing is very much important thing, and you need to use this concept to measure any angle or any length of this thing. So let us discuss one example first about this question, so that it gets some easy. You get convinced about this thing. So the question is like, okay, if the arc of the same length two circles is subtend 60 degrees, not like that. Okay, we can use this thing. So in a watch, suppose the minute hand has length 1.5 centimeter. Okay, now if it rotates 4 pi by 3 radian, 4 pi by 3 radian, this is the measure one particular value of the radian. Okay, this radian, then how far does its tip move? This is the question. So first understand this question properly. So this is clockwise direction. So in this case we are not bothered about anti-clockwise or clockwise direction, but okay, that is not that much worried. That clockwise and anti-clockwise direction is much more important in the case of degree measure. Also radian measure is also there, but in this case you don't need to bother about those things. So just understand this thing like this way. So obviously it is in the clockwise direction, because clockwise direction means clock always rotate in that direction only. So yeah, this is suppose your previous position of the minute hand, which is length 1.5 centimeter, and after certain time it went to this part. Okay, so the hand is not, the measure of the hand will not change, because you know that watch has a fixed hand and it always remains unchanged. It don't change its length with time. Okay, so this is the angle between them, and this is called 4 pi by 3 radian. Now what they are asking, the tip, movement of tip, that is, this is our tip. So how much movement it has done in this time. So suppose this is our L, this is our R. So R is equals to, here R is equals to 1.5 centimeter. We need to know about L, and we have the angle between them, which is 4 pi by 3 radian. Theta is 4 pi by 3 radian. 4 pi by 3 radian. Okay, so you need to find this L. How can we find? So you can use this formula. This is your formula. So L equals to M into R. L equals to M into R. So what is our M? 4 pi by 3. And what is our R? 1.5 centimeter. So this gives us the value of pi and all these things. So it will give around 6.28 centimeter. So the length, or you can say the movement done by the tip of the minute hand, will be 6.28 centimeter. Now one can also measure the thing, like if someone do this thing, 6.28 divided by 1.5, this will give the radian measure. This is what it is. Now before going to this thing, you should always careful about. You should be always careful about this units. You must observe that whenever you are finding the radian measure, the unit of the length should be same. Usually students do some mistakes, like in either case it is millimeter and another case it is centimeter, and they didn't observe these things and they do the usual calculation and find some radian which is wrong. Okay, so be careful about this thing. Okay, so till now we are aware of the radian and we are aware of the degree measure. Okay, now we will discuss the relationship between radian measure and real line or real number. Real line or real number, you can say. Okay, relation between radian and numbers. Okay, so for this we can draw a picture first. So let us draw a picture. So this is our origin, this is the initial state, this is the terminal state. You can draw a dash. Now suppose this length is 1, so I am drawing a unit circle like this. This is our unit circle. Okay, this is the origin and this length is suppose 1. Now let us draw this point as origin, and let us draw a tangent to this point like this. And this is our origin. This is 1, this is 2, this is 3, this is -1, this is -2, this is -3, and so on. It is going. Now observe one thing. This arc length, this radius are 1. Both the radius are 1. Okay. Now if I wrap this line, this blue line, you can see this blue line, this is the positive direction of the numbers. If I wrap this line on the circle, then what will this one gives us? This distance gives the arc length from here to here, right? What this distance give us? This distance give us the arc length from here to here. Similarly, what this distance gives us? This distance gives us the arc length from here to here. Similarly, arc length from here to here we can obtain from this length. So one can clearly see the numbers, the natural numbers, or you can say the integers, are related to the 1 radian, 2 radian, or integer radian numbers. So if and other real numbers, like every real number is related to some radian number. Okay, and depending on that thing we can get 1 radian, 2 radian, and so on. And now you can say that these number sets are infinite. You can see this number is infinite. That's why I told that in this case you don't need to worry about positive, negative, because if you wrap the real numbers, then you can see that the blue line will wrap this circle again and again and again, like this. like this. Okay, like this, again this, and so on. And similarly, this, if I talk about this red line, that is negative direction, let's also wrap this thing along this like this. Just the direction remains changed. The direction goes changed. Okay, the direction goes changed. So thus a radian and a real number is related very much. Okay. Now, what is the relation between these two angle measurements? These two angle measurements. What is the relation? So, just come here and look at the white circle. So, white circle is the circle of radius 1. So, what is the length of this perimeter? What is the length of this perimeter? This length of the perimeter is 2 pi. Right? So, a complete revolution. So, a complete revolution is equals to 2 pi distance covered in real line. Right? So, if I compare this with this concept, then I can say the distance covered, so complete revolution done. If I by this initial state and the terminal state do a complete a whole revolution, a complete revolution is done, then the distance covered by the terminal state from the initial state is 2 pi. So we can say a complete revolution equals to 2 pi radian.